So this is chapter 4.1, problem 33 in the text, page 162. We're going to be discussing scatter plots and correlation. The NFL Scouting Combine is an event at which football scouts evaluate the abilities of some top college prospects. Following are the heights in inches and the weights in pounds for some of the quarterbacks at the 2013 Combine. Here they are, and there is approximately 14 individuals that make up this sample. The first question is creating a scatter plot of weight based on height. Here we are expecting the height to be the x variable and weight to be the y variable. So in this case the height is in fact the explanatory variable and weight is supposed to be the response variable. So to do the scatter plot, we're going to use Excel this time. We will enter the data into two columns with the first cell in each column having the label height and the second column having weight. That's step 1. Step 2, go to the Insert tab at the top of the spreadsheet and move your arrow key over Charts and choose the Simple Scattered Diagram chart. Make sure your cursor is in some empty cell next to your data set or a little farther away from your data set. Choose that scatter chart, and once that chart is selected, a blank square will show up on your screen. Highlight the blank chart and select Data from the top menu screen, or Select Data from the top menu screen. Add the X data height first and click OK. Then move to the Y data and enter the weight. You will move the cursor down and highlight all the weight data and then click OK. Once you do that, you've seen that the data chart will look everything except for your access titles and your actual chart title. You can add those with highlighting the chart, and next to there's a plus key. You can highlight the plus key and add in the titles for both the axes and the top chart, in which case we've done here. So here is the Excel scatter plot. You can see the plots of the weights based on the heights. Doesn't look very linear, does it? In question B, it asks to calculate the correlation. Again, we're going to use Excel. So in Excel, we created the two columns, height and weight, and at the bottom we typed in correlation in the bottom of the cell under the height, and then we move the cursor over to this cell here. We highlighted that, and so we press the equal key from that cell, and we looked up the function correl, which means correlation. We press that function, and a menu screen opens up to ask for two arrays. We highlight the height column into array 1. And then we highlight the weight column in array 2. We click OK, and then we see the measurement of correlation. In this case, R equals 0.33. So we're going to finish the answers in problem 33. Problem C asks, if a quarterback is below average in height, would you expect him to be above or below the average weight? Well, we found out that the average weight is 75.71 inches. The mean weight of these quarterbacks was 227.5 pounds. When we looked at the data, we found that 8 quarterbacks are below the 75.71 inches, and of those 8, 6 of them are below 227.5 pounds. Our expectation is if the quarterback is below average in height, they would also be below average in weight. Why? Because 6 out of 8 is approximately equal to 0.75, or 75% of those quarterbacks that are below height are also below the average weight. Part D says, which of the following is best interpretation of correlation? 1. If a quarterback gains weight, he will grow taller. No, that's not correct. Given 2 quarterbacks, the taller one is likely to be heavier than the shorter one. Well, that appears to be okay. And finally, the last one, given 2 quarterbacks, the heavier one is likely to be shorter than the lighter one. No, that didn't make any sense either. So our answer is number 2. That's our interpretation of correlation in this particular case. Well, that concludes this problem 33.